There are two more examples I want us to look at for solving linear inequalities. We have a couple of compound inequalities we want to look at, and they're kind of special, and let's see why. So in order for us to figure out what's going on here, other than the fact that this and means intersection, we have to solve these individual inequalities first. So this guy, we divide both sides by -3, and we come up with the inequality that x, notice that we divided by negative, so that means we have to change the direction to be less than or equal to, this is -5. For the other inequality, we subtract 5 on both sides. So that gives me x is, let's see, subtracting 5 is not division, so it stays as greater than, and this becomes 14. When we talked about doing intersection before, we said how we would mark off these values on the number line, and on top of the number line we would just graph each of these guys so we could see where their solution sets are. So let's do pink for this guy, less than or equal to -5. So that's including -5 and going to the left. And then I'm going to do blue for this guy. He is greater, so he's going to be open circle at 14. X is greater, so that's going to the right. And so the question becomes, where's the intersection? Where do these guys overlap like we've seen before? These guys don't overlap. So where's the intersection? Well, there is no intersection. So that means an example of having no solution. There is no value of x that's going to satisfy this inequality and that one at the same time. It's just not possible. So the answer here is no solution. All right. Well, let's take a look at this next one. We see that we have the word or, and we know that the word or means union. And again, union means just put everything together. But before I can do that, I need to go ahead and solve each of these inequalities. So first, I'm going to subtract 4. That gives me x is greater than -3. And over here, I'm going to divide both sides by that coefficient of 5. Dividing by positive, so no change to the direction here, so x is less than 7. All right, so put all of these guys together. There's -3, there's 7, and let's see what we get. So since I'm putting these guys all together because I have a union, I don't need to do anything above the number line. I just throw it all on the number line and see what sticks. Greater than -3 is open at -3, going all the way to the right. Less than 7 is open at 7, and he goes all the way to the left. So when we talk about the union, when we talk about putting everything together, well, what did we color on the number line? Well, we colored everything. Even though we had an open circle here, this less than 7 went through it and filled it in. The same thing with the open circle here at 7, because when he started with greater than -3, he went through 7, in essence including that in the solution set. So here we're including everything on the number line. We're including everything from -infinity to +infinity. Another way of stating this is that our solution set is all real numbers. So here you go, a couple of examples of some kind of oddballs that we see here with compound inequalities, but you need to know these guys so that when you jump into your My Math Lab homework, you're not going to be fooled.